Hi, I'm Mr. V. Today's lesson from Illustrative Mathematics in Geometry is about solid geometry. Lesson 5, Scaling and Unscaling. And by the end of the lesson, you should be able to say, I can use square root graphs and do calculations to interpret the relationship between scale factors and areas, blah, 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 blah. We'll see it when we get to it, using square root graphs. And much of what we're going to do is depending on the formula that we looked at yesterday. So this first question, this image of the Transamerica building in San Francisco, it's shaped like a pyramid. The bottom floor is a rectangle measuring 53 by 44 meters. And the top floor of the building, which is where these windows are, not where these triangle shapes are, not where this part of it is. This is like for the antennas and the radio part, and this is for the heating and cooling, and the elevator goes in this top part. So this top floor is a scale factor of 0.32 of the base. So using what you know about this, without excluding the wings, what is the area of this top floor? That's the question. And so let's ask it. Let's look at it. And I'm going to show you my whiteboard. We'll do this on my whiteboard. To solve this problem, I'm going to show you a couple of ways. Maybe you are one that looks at the length and width of a rectangle. So here we have a rectangle, and it's got a length of 53 and a width of 44. And we're going to scale this up. To get to the smaller one, which is way up high, we have to take this original and multiply it by 0.32. And we have to multiply the 53 by 0.32. And the area of this figure is going to be 53 times 0.32 times 44 times 0.32. But wait just a minute. We also have a formula that says that the area that I'm starting with, a subscript 1, sub 1, a sub 1, and we multiply that times the scale factor squared, is going to get me to my new area, a subscript 2. This does not mean a squared. This is squared. It's a superscript. This is a subscript. We say a sub 2 is equal to k squared times a sub 1. What do you think those subscripts mean? Well, the a1 is where we're starting from, and the a2 is where we're ending at. And you may recall yesterday when we had a little rectangle, and we're going to scale it up by 2. Well, we scaled up this section by 2, and we scaled up this part by 2. So we ended up being, if it was scaled up by 2 and by 2, my area went up by 2 squared, which was 4. That's what this number is all about. And this is what we did yesterday. Well, we can take these numbers and plug them into the formula. So we have k squared, which is 0.32 squared. And the area of this original was 53 times 44. But wait a minute. That's the same thing as I'd get if I scale the one length and scale the other length. This business of scaling the lengths, we have our length that we started from times the scale factor is equal to the length that we end at. Length sub 2 is equal to the k value, the scale factor, times the length sub 1. And these are equal. And we can plug them into a calculator. And when we do that, let's just do that. I have 0.32 squared, right arrow, times 44 times 53. I get 238.8. 238.8. And this is going to be, I have meters times meters, so it's going to be meters squared. That's a pretty good size chunk of real estate. I mean, I don't have a house that's big. That's pretty big. That's really quite big, actually. Yeah. Like our houses right now. All right. It would be almost like 2,000 square feet if you had a house that big. So we go to the next section. On the question on page 5, it says, did you find the dimensions of the top floor and then multiply it by the area? Or try the area? Or did you multiply the bottom area by k squared? Both of these cases work. These are two different ways of solving the same problem. One uses the length squared, right? This part here, the length, the new length, and the new width squared. The other one takes the area and it multiplies it times the k value, the scale factor squared. So both of these are the same. If you don't get that from yesterday, make sure that you get it, because that's really, really kind of important. All right, moving on. Let's see. The next part of this lesson, you have a triangle that has an area of 100 square inches. It's dilated by a scale factor of 0.25, which is 1/4. And Mai says the dilated triangle's area is 25 square inches. And Lynn says the dilated triangle's area is 6.25. With whom do you agree and why? And then on the next page, you're supposed to answer the person that you didn't agree with. How could a person get that for their answer? If you didn't agree with them, you're not telling me how you got your answer. You're telling me how someone might get their answer. And then the final one is to calculate the area if the scale factor is 9 or if the scale factor is 3/4. I want you to try these on your own before you actually just look at my answer. But I'm going to show you how I would go about doing this. The first thing I'm going to do is write the formula, substitute the values, and solve. So my a sub 2, where I'm going to, is equal to my scale factor squared times my area sub 1. We know the area sub 1, that's 100. And we know the scale factor. So we can substitute these values. If I take this, I'm going to do it as 1/4. 1/4 is 0.25. And I square it and multiply it times 100. Well, if I multiplied 1/4 times 100, I'd get 25. But I have to multiply that times 1/4. So Lynn is the one that is correct. If you actually plug this into a calculator, which I'll do, I'll show you. 1/4 squared, so I'll take my value here, parentheses, 1 divided by 4, I could do 0.25, squared, I'm going to multiply that times 100. It's 6.25. Now let me show you why this works, because this is correct. It's 6.25. What the person did here was they have multiplied it by k instead of by k squared. That's what that person did that was wrong. What if I had a triangle like this, and I cut the sides in half? So I'm going to cut it in half here, all the way across, cut it in here, all the way across, and I'm going to add this diagonal too. Well, if I cut this in half, I'm going to have 4 triangles. So if my original was 100, then I take 1/4 that. Each one of these is going to be an area of 25. That's true. If my scale factor was, if my k value is 1/2, because I'm cutting it in 1/2 this way and 1/2 this way. So I take my area times is equal to the k squared times the area 1. So if I have 100 and I multiply it by 1/2 squared, then I get to 25. That's what May did instead of Lynn. If I instead take that part and I cut it in half, so I'm going to go half this way, I'm going to go half here. So now I've got 4. Instead of making this fake, my k value here is going to be 1/4. I also have to do it 1/4 going up and down. Let's see if I can do this right. I'm going to do it this way, and I have to do here, going across, and like this. How many triangles do you see? 1, 2, 3, 4, 5, 6, 7. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There's 16 of them. And if I scale it by 1/4, one of these is going to be 6.25. That's 1/16 or 1/4 squared. 1/4 squared times 100. It's 1/16 of 100, which is 6.25. Now, 2 of these would give me 12.5. 4 of these would be 12.5 plus 12.5, which is 25. That's the area of one of these triangles. Yeah, 6.25 is correct. All right. And what if we did these other, let's see, questions for discussion, activity synthesis. Let me see. I'm supposed to calculate when my scale factor is 9 and my scale factor is 3/4. So let's do that. Let's see if we go down 1. When my scale factor is 9, My area 2 is equal to my scale factor squared times my area 1. Area 1 is equal to 100. Area is a sub 1. So I have 100 times 9 squared. And my answer is 8,100 inches squared. I put the units in brackets. I prefer that you do that. And then you circle your answer. If I do this with a scale factor of 3/4, when I substitute the values, I have 3 over 4 squared times 100. And I'll plug that into the calculator. There's other ways that you could go about solving it. Plugging into the calculator is fair. I mean, you can do that. It's not a problem. So I have 3 over 4, parentheses, squared. I have to do a right arrow times 100. And I get 56.25. And that makes sense. This is going to be inches squared again, units in brackets. And the reason it's going to be small, it's smaller than 100. I'm scaling back. It's not 3/4 of 100. That would be 0.7. That'd be 75. But it's 3/4 times 3/4 times 100. So it's the scale factor squared. And that's a big idea from yesterday. In a minute, we're going to show you what we're going to do with this today, which is a little bit different. So, questions for discussion. Why didn't we need the dimensions to calculate the area? Well, the area is proportional to the scale factor squared. You don't need to know what the dimensions are to find the area. If you're given the area, you can just use the area. And some ways of dealing with 3/4, well, there's some different ways that you could use. We just stuck it in a calculator. And now we got the graphing and scale factors. Look at this question. An artist is painting a painting. It's 1 square foot. And the paint is really expensive. She wants to paint it and scale it up. And she wants to know how big of a painting can she get if she scales it to cover 9 square feet. In other words, what is the scale factor? Basically, what she's asking is, if I know the area that I'm ending with, and I know the area that I'm starting with, what is the scale factor? What is the K value? We start with 1. We go to 9. And what is the scale factor? Well, K squared is equal to 9. To do the inverse of squaring, we'll take the square root. The square root of 9 is 3. What if my value is 4 is equal to K squared times 1? When I take the square root, I get K is equal to 2. What if it's 16 is equal to K squared? Well, you're going to get a value of 4. And you could actually fill in a table with these different values. If it's 0, that's my point of dilation. It has no value at all. If it's 1, it's going to be what I started with. And my starting area was 1. We said if I scaled it up to be an area of 9, this is my area. My original area was 1. And this is my scale factor. So to get 9, I had a scale factor of 3 because K squared is 9. If my scale factor was 4, I would get 16, and this is 2. And you could plot these points, and you plot them on a grid. This would be my area in square units, and this would be my scale factor. Just like on our grid here, we have, this is my Y value, and this is my X value. So how does the scale factor change with area? And here's the question. So if I have 0, 0, notice this is 1, 2, 3, 4. So at 1, I'm at 1. At 2, I'm going to be an area of 4. At an area of 9, I'm at 3. At an area of 16, I'm at area of 4. So I'm at scale factor of 4. So this is the way it looks, something like this. It's not a line. It's a big curve. And what is this a curve of? This is the curve of the graph. Y is equal to the square root of X. Where do I come up with that? Well, if you have area 2 is equal to K squared times area 1, and you know both of these two, you can divide both sides by this. So you get A2 over A1 is equal to K squared. And then you take the square root of both sides. So K is equal to the square root of A2 over A1. In our case, A1 was equal to 1. So we just had Y is equal to the square root of X. K is equal to the square root of this. Scale factor, K, and that's what we have here. The scale factor, this is our Y value, this is K, is equal to this. And a couple of questions come up in the discussion. One is that if I have 12 square units, enough paint for 12 square units. Looking at the graph, I could do the square root of 12 and then get my y value, but I'm just looking at the graph. How much of a scale factor is this going to be? And it's going to be like 3.5. One of the other questions that comes up in the discussion is that if I start off at 1, I'm going to add enough paint to go an extra 2 square feet. How much does my scale factor go up? My scale factor goes up like 3/4, almost a full scale factor up. But if I go over here from 14 to 16, and I'm going to add enough paint to go up 2 more square feet, then how much does my scale factor goes up? Well, it goes from like 3.75 to 4. It doesn't go up very much at all. This distance is a lot less than this one. So why is that? Well, it's steeper at this end of the graph, and this gets flatter and flatter, and so that's part of the reason why. Where are we? There is a activity synthesis and a lesson page that you should read when you do this problem. And then for the shutdown, for the close down, you have this toy train set. It includes a train station building, which is a scale model of the real thing. The area of the toys model of the train station has a front of 1 square foot, and the real building has 400 square foot. So what is the scale factor? And you should do this on your own. I'm just going to show you if I have my area 2 is equal to k squared times area 1. The area 1 is 1 square foot times k squared is equal to an area of the real one is 400 square feet. When we take the square root of both sides, we get k is equal to the square root of 400, which is 20. So the scale factor is 20. 20 in the length and 20 in the width, which will give me to 400 from a unit of 1. And folks, that's all I've got for today. Good luck and success.